Okay? So this little unit, it's only 2 sections, so we won't be having a full-blown test. We'll have a quest over these 2 sections, okay? First 2 things on 9.4, it says arithmetic sequence, and I know the word looks like arithmetic, but when we use it as an adjective, it's arithmetic. So we have an arithmetic sequence and a geometric sequence. Okay, would somebody give me just any sequence of numbers? Just a sequence of numbers, just rattle off some numbers.
5, 6, 7, 8.
Okay, 5, 6, 7, 8. 5, 6, 7, 8. I'll just put a dot, dot, dot on there because we could sure keep going, couldn't we? 5, 6, 7, 8 is an example of an arithmetic sequence. Because how do we get from term to term? Like, how do you know what comes after the 8? You're adding 1. You're adding 1. And when you add the same number, as you go down the line, that's an arithmetic sequence. That's what makes something arithmetic. You are adding the same number. Now, does that number have to be 1? Absolutely not. Can you give me an arithmetic sequence that we're not adding 1, but we're adding something else? What would be an example? Eddie?
2, 4, 6, 8.
2, 4, 6, 8. This one is also arithmetic because what makes it arithmetic? You're adding the same number, and in this case, the number you're adding is 2. Now, arithmetic sequences can actually go down. So for example, if I have this one, what's going on here? What am I adding in that one? Well, when you say I'm subtracting, subtracting is the same as adding a negative. So here I am adding negative 3.
Yeah.
Now the number that we add, so here it's 1, here it's 2, here it's negative 3. The number that we add is called the common difference. And I'm not going to go through how to derive this formula, although it's very easy to derive. What I need you to write down there, up there where it says arithmetic sequence, I need you to have 2 things written down. You can also have this if you want, but the 2 things written down are, you get from term to term by adding the same number. That's what arithmetic means. And then I want you to write this formula. I want you to write it just like that. So make sure you have that written down, and I'm going to talk to you about what all those things mean. So the letter A stands for a term. When you put a 1 on it, that means the first term. So this guy right here means first term. Any idea what the D stands for?
Difference.
That's your common difference. So if I were using the formula on my sequence, I would put a negative 3 right there. N is the number of terms. So 1 means first term, and N means the nth term. So A sub 6 would mean the 6th term. Now we'll see how this works when we do some examples, but I need you to have 2 things written down for arithmetic. What's the definition of an arithmetic sequence? You get from term to term by adding the same number. And then the formula for arithmetic sequences is right there. We'll practice with the formula, so don't worry, just get it written down. All right, now I'd like you to think about this sequence. Is that one arithmetic? No, because we aren't adding the same number. Here we are adding 2, here we would add 4, here we're adding 8. That is not arithmetic. There's a pattern for sure, but it's not arithmetic. What's happening? I'm multiplying, in this case by 2, but it's the same number. When you get from term to term by multiplying by the same number, your sequence is geometric. So a geometric sequence is like this one. We get from term to term by multiplying by the same number. So can you give me another example of one where I'm multiplying by something other than 2? Let's multiply by something other than 2. 4, 16, 64. What am I doing there? Multiplying by 4. The number that you multiply by, in my sequence it was 2, in Grant's sequence it's 4. The number that you multiply by in a geometric sequence is called the common ratio. The common ratio. And the formula, this is the number you multiply by. So, my common ratio was 2, and Grant's common ratio is 4. The formula for a geometric sequence, remember, this is the formula for arithmetic. If you have a geometric sequence, your formula is this. Now, all of the letters mean the same thing. So A sub 1 means first term, just like it does up here. It's the first term. What do you think the R stands for?
Ratio.
The ratio. So in my problem, R would be 2. In Grant's problem, R is 4. And N is, of course, the number of terms. So if you had A sub 10, then you would be talking about the 10th term. All right, so that's just basic vocabulary. One more time, because this is crucial. How do you know a sequence is arithmetic? You're getting from term to term by adding the same number. If it's geometric, you're getting from term to term by multiplying by the same number. If a sequence is arithmetic, this formula applies. If it's geometric, this formula applies. Are there sequences out there that you don't get them by adding the same number, or you don't get them by multiplying by the same number? Sure. There are lots of sequences that aren't arithmetic or geometric, but our focus is on those two kinds. All right, so here we go. Number 1, identify as arithmetic, geometric, or neither. And I'm going to also ask you to put down, if it's arithmetic, what's the difference? If it's geometric, what's the ratio? So let's look at problem A. What seems to be happening in problem A? Dividing by 2. Well, we don't really have a sequence that says we divide. Dividing by 2 is the same as what? Multiplying by 1/2. So A is geometric, and the ratio is 1/2. In sequences, we either add or multiply. So sometimes we do fractions to make that happen. So A is geometric, and we are multiplying by 1/2. Okay, what do you think about B? Eddie? So it's arithmetic because we keep adding 10. And if you keep adding the same number, it's arithmetic, and that number is the difference. So it's arithmetic with a common difference of 10. Perfect. Okay, what about C? Adding 8. So it's arithmetic with a common difference of 8. what seems to be happening in D?
It's like adding the number that was before it.
So, we go from 3 to 5, that would be plus 2,
Yeah,
and then we go plus 4,
yeah.
and then plus 6. Oh, there's a pattern there, 100% there's a pattern there. Could you keep going?
Yeah.
Yeah. Is it arithmetic though? No, because what does arithmetic mean?
It's adding by the
You
same.
have to be adding the same number, and we aren't. So that is an example of a neither. Need you to understand that neither means you're not adding the same number, you're not multiplying the same number. It does not mean there's no pattern. There's almost always a pattern of some kind. It just isn't arithmetic or geometric. All right, what about E?
Geometric ratio of 2.
Yep, geometric, we're multiplying by 2. So geometric ratio is 2. You even use the right vocabulary. Good job. All right, what about F?
Plus 2.
Plus 2, which makes it what?
Arithmetic.
Arithmetic with a common difference of 2. Perfect. All right, what about G?
Neither.
Neither one, yeah. Now G is a pretty important sequence of numbers. What do you notice about it? You notice anything about those numbers? What are those numbers? 1 and 4 and 9. Those are the squares. So definitely there's a pattern. What would come after 25? 36, and then 49, and so on. There's a definite pattern, but it is not arithmetic or geometric. So G is neither one. All right, everybody okay there? All right, number 2. Do not be confused by the notation. There is a sequence of numbers. I don't know if it's arithmetic or geometric or neither. It doesn't matter. They've given me a little formula and said b sub n equals 6 over n. Then they say find b sub 1. Now, if we're finding b sub 1, then aren't we letting n be 1? And if we let n be 1, what does it equal? 6 over 1 or 6. And then what about b sub 2? What will b sub 2 be? 6 over 2, which is 3, very good. And then what am I doing? B sub 3 and B sub 4. And B sub 7. All right, what will B sub 3 be? Now get used to using these formulas, guys. B sub 3 means let n be 3. So if we let n be 3, we have 6 over 3, which is 2. And then we have 6 over 4, which is 3/2, or 1.5. You'll have a calculator for this test too. And then what about B sub 70? What's B sub 70 gonna be?
6 over 7.
6 over 70, or 3 over 35 if I divide everything by 2. Another one, same exact idea. This time they called it C, doesn't really matter what they call it. Alright, here we go. Can you figure out what C sub 1 is? This is called C sub 1, and clearly we're letting n be 1. So what will C sub 1 be? 2 times 1 plus 1, which is 3. Now, most of you can do that in your head, so you can write all that down. If you plug in a 1, you get 3. Alright, C sub 2, I'm going to plug in 2, and if I plug in 2, I get 5. Is that right, everyone? all, what, 6 of you? And then if I plug in 3, I'll get 7. 4 gives me 9. And then 70 would give me 141. All we're doing when we say C sub 70, we're letting n be 70. So we put 70 in there. 2 times 70 plus 1. Okay? So, problem 3A says I have an arithmetic sequence. Now, they really didn't need to tell me that. Can you see that's arithmetic? Why is that arithmetic? We're adding -4, so our common difference is -4. One of the things we had to find was the common difference. We've got it. Okay? Now, since it's arithmetic, this formula will apply. This is the one I had you write down for arithmetic. You do not need to memorize the formulas, although there aren't very many, and usually after you've done, so many problems, you'll have it memorized. I will give you the formulas. All right, so this is the formula for arithmetic. The question says, find the common difference, we already did that. Find the 8th term. Now the 8th term will be a sub 8. That's, n is the number of term. So if you want the 8th term, n's gonna be 8. According to the formula, the 8th term is gonna equal the first term, which is 3, plus the common difference, which you said was -4, times n minus 1, but guys, these are the same n, and what did you say n was in this problem? 8, so this is gonna be 7, n minus 1, 8 is n. That n is the same as that n, always. So if this were a sub 10, that would be a 10. All right, so -4 times 7 is -28, and -28 plus 3 is -25. So the answer to the problem is, the answer to that problem is -25. Now, I always have kids ask, and you might be thinking this, Mrs. Ford, couldn't I find the 8th term by just keeping this sequence going, like -4, -4, -4, and the answer is 100% absolutely you can. The drawback to that strategy is, what if we wanted the 800th term? I don't think you want to keep writing this out all the way to the 800th term, but does it really matter? If it's the 800th term, wouldn't I just put 800 in here and work out the math? I can find any term I want with my formula. Snap of the finger. All right, last part of the question says, and the explicit rule. Now, that sounds very hard, but it is super simple. I want you to come back to your formula. And this is the formula you're going to use every time your sequence is arithmetic. And I want you to put in what you know. So we know the first term. So I'm going to put 3 in there. That's the first term. I know my common difference is -4. So I'm going to put that in there. That's all I know. I can figure other things out, but right now, all I know is that the first term is 3 and the common difference is -4. This is going to be our explicit formula after we clean it up. So, I'm going to distribute here. So this is gonna be minus 4n plus 4. Would you agree with that? So what does a sub n equal when I collect like terms? 7 minus 4n. And that is your explicit formula. The explicit formula is just your general formula with your first term and your common difference plugged in. Plug in these two things, because you know those. And that will give you your explicit formula. Alright, let's try B. B is the same sort of thing. Same questions are being asked. They told us that the sequence is arithmetic. Would you agree with that? Would you agree that problem 3B is arithmetic? Yeah? How do you know? Aren't you subtracting a half?
Yeah.
So that's your D. I'll use a decimal, you could use fraction, doesn't matter. Since these are decimals, I'll use a decimal. So now, if I want the 8th term, a sub 8, here's my formula right here. What do I need to do to find, well, really any term, but the 8th term specifically, I have to let n be 8. And then what does that equal? A sub 1, which is 10. And then plus negative 0.5 times n minus 1. But what's our n in this problem again? 8? So that'll be 7. Who's got a calculator? What is 10 minus 0.5 times 7? 10 minus
7.5.
I'm getting 6.5.
Oh, yeah, you're right.
6.5 is the 8th term. All right, now we want the explicit formula. So again, go back to your arithmetic formula. And what did I tell you to plug in? What we know. And what do we know? We know the first term is 10, and we know the common difference is negative a half. So a sub n equals 10 plus a negative or minus a half times n minus 1. So it's my arithmetic formula. I'm putting 10 in here, and I'm putting negative a half in here. So now I'll distribute. So that's 10 minus 0.5n plus 0.5. Remember, you're distributing the negative. So what is our explicit term for this problem? A sub n equals what? 10.5 minus 0.5n. You with me, Sharon? Perfect. All right, one more. Try this one on your own. See if you can do what we just did. Answer all the questions we just did. I'll read my formula right here. This is the formula I use whenever my sequence is arithmetic. So I guess the first thing you want to do is confirm it's arithmetic. Quinn, do you think this is arithmetic? What am I doing here to get from term to term? What do I seem to be doing?
Adding 6.
That it's arithmetic, right? And the common difference is 6. Now, find a sub 8. do what you need to do to find a sub 8 using this formula right here, letting n be 8. Anybody have an idea? What'd you write down to find a sub 8? You wrote down what? 10
plus 6.
plus 6.
Parentheses, 8 minus 1.
8 minus 1. I'm just gonna write 7,
Yeah.
but it is 8 minus 1.
And then
So hopefully you got 52 as your answer.
Yeah.
Now, all these problems are using a sub 8, but could we find a sub 20 the same way?
Yeah.
The only difference would be, instead of being a 7, that would be 20 minus 1, or 19.
Yeah.
And that would be your 20th term. Isn't that a cool formula? Yeah. Oh yeah, that's a cool formula. All right, and now we need the explicit rule. So we go back to here, and we plug in this number and this number. That's all we plug in. So if we did that, a sub n will equal what? 10 plus 6 times n minus 1? So that's 10 plus 6n minus 6. Did anybody get 4 plus 6n
Yeah.
as your explicit formula? Perfect. Right now, we're going to do what some kids find really hard. I don't think it needs to be, but some kids think it's hard. We have an arithmetic sequence. We are given this information. Now, can you tell me what that information is? What does this mean?
The fourth term.
Fourth term. So here's my sequence. Blank, 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 13.
Yeah.
And then blank, blank, 22.
Yeah.
So that's what my sequence looks like. Would you agree with that? Now, your job is to find this number and the 100th number. Now it's arithmetic, which means it's going up by the same amount each step, right? So we can do this with math, or we can do it with our common sense. We went from 13 to 22. What kind of a difference is that? I mean, how much is that? 9. So, we skipped 2 steps and ended up going up 9. Well, what if we skipped these 2 steps? Going backwards? Then wouldn't we go back 9? Does that make sense to you?
Yeah.
Remember, every step is equal. So if these 2 steps, if bing, bing, bing adds 9, then we'll bing, bing, bing subtract 9, making this number a 4. Does that make sense to you? Now, if bing, 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 basically 3 steps, 1, 2, 3, added 9, and every step is the same size, because that's what arithmetic means, How big are the steps? Watch it. Be careful. 1 step, 2 step, 3 step. So in those 2 blanks right there, aren't there actually 3 steps happening? 1, 2, 3 steps. So if the total was 9, then doesn't it look like we're adding 3? Let's see if it works. That would make this 16, this 19, and that 22. So not only have you figured out that your first term is 4, but now you know that your common difference is 3. Kids, that's just logic. We can use formulas to do that problem, but it's going to be harder. Think about what's happening, and remember that you are adding the same number. Now, look at our formula. I need to find the 100th term. Could I keep adding 3's? Yeah, but it would take forever. So I'm going to use my formula for this one. The 100th term, is going to be the first term, which you figured out is 4, plus the common difference, which you figured out is 3, times what? N minus 1 will be 100 minus 1, which is 99. So you're gonna have to help me out. What is that?
297.
That's 197. 297.
Yeah.
And I have to add 4 to that.
301.
301. So the 100th term is 301. That's tricky. Absolutely, that's tricky. All right, so now I got the next one. It says the third term, so there's a couple blanks. The third term is 8. 4th, 5th, 6th, 7th term is 36. So this is what it looks like if I write it out. It says term number 3 is 8. That's 3, so 4, 5, 6. Term number 7 is 36. Does that make sense to you? Now, how far is it from 8 to 36? What is that distance there? Is that 28?
Yeah.
The distance is 28? And how many steps did it take me to get that 28? 1, 2, 3, 4 steps to get that 28? So what does that make my common difference? If it took me 4 steps, 7, so the distance or the difference is 7. Let's check it. 8 plus 7, 15 plus 7, 22 plus 7, 29 plus 7. Does it work out? Yep, so my difference is 7. Now, going that way, I am adding 7 with each step. So going this way, I will be subtracting 7. So this will be 1. And this will be -6. And that's your first term, guys. Your job was to find the first term and the common difference, and you have done it basically by counting. Now, what's the 100th term going to be? Let's clear out here somewhere. What's it going to be, the 100th term? Well, look at your formula. A sub 100 will be what? -6 plus 7 7 times 99. Okay, what's negative 6? Negative 6 is the first term. 7 is the common difference, and n is 100. So what'd you get for that one?
687.
687. All right, one more. One, two, three, four, five, sixth term is negative 1. 7, 8, ninth term is negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so there's a picture of what's happening. See if you can figure out what the first term is, this number right here, see if you can figure that out. See if you can figure out the difference, and then you can find the 100th term. So take a minute and try that. Okay, so are you thinking that you gotta get from negative 1 to negative 10, which is a distance of how far? What's this distance right here?
9.
Negative 9 actually, isn't it going down? So it's negative 9 total. And I'm gonna do that in 1, 2, 3 steps. So if I'm going negative 9 in 3 steps, each step must be negative 3. So that's your common difference, negative 3. Now, I need my first term, which is way back here. Remember that negative 3 is going that way. So I subtract 3, subtract 3, subtract 3. So negative 4, negative 7, negative 10. If I'm subtracting 3 going that way, then what am I doing going this way? Adding. So this one was 2, 5, 8. You got a calculator, you can just keep hitting plus 3. 11, 14. And that's the one I want, right? The first term. So that I can do my formula, which says the 100th term is the first term plus the common difference times n minus 1, 100 minus 1. So what's 14 minus 3 times 99?
Negative 269.
Negative 269? We're typing it in our calculator, guys. It's easy.
But I got negative 283.
Oh wait, so did I. Oh, I added 14 twice.
No.
But I did, yeah, I got 3.
What is it?
283.
Negative 283. Okay, all we're doing is typing it in, right? So we can't throw in this unless we add 14 twice. All right, what about, let's just talk about this very last problem. Is there anything about this very last problem that didn't make sense to you? Because I'd really rather not do it out the whole formal way. It's a lot harder. So, but did every step here make sense to you? because now we're going to graduate onto part 5, which are geometric sequences. Now, for our geometric sequences, guys, we will not be using this formula, so I'm going to erase that formula. Who can tell me, because you wrote it down in your notes, what's the formula for a geometric sequence? A sub n equals A sub 1, very good, times r to the n minus 1 exponent. And r stands for the common ratio, which is the number that we multiply by to generate the sequence. It's geometric, so we're multiplying. All right, so 3, 6, 12, 24. Directions say, what's the ratio? 2. Aren't we timesing by 2, guys? Yep, can't miss on that one. That's the ratio. Oh, what's a sub 1? 3. What does a sub 1 stand for? First term. This means first term. It always means that, whether it's arithmetic or geometric, a sub 1 means first term. And now we want a sub 10. How are we going to do that? How are we going to find the 10th term? We're going to take, here's your formula, right?
Yeah.
So we're going to take, we're going to put 10 in for n. So we're going to take a sub 1, which is 3, and we're going to times it by 2 to the 9th. And that is definitely a calculator problem. 3 times 2 to the 9th, and type it in just like that, you should get 1536. Is that okay with everybody? All right, how about this one? What's happening in this one? They tell me it's geometric, so I must be multiplying by something. What am I multiplying by? 1/8? Now, if you said you're not multiplying, you're dividing, remember, division is multiplying by a fraction. And we gotta think about it as multiplication. So, would everybody agree I'm multiplying by 1/8?
Yeah.
And my first term is actually 8. So the 10th term for this sequence will be what? 8, here's your formula, times 1/8 to the 9th. Now if you type it in exactly the way I wrote it, you'll be just fine. So 8 parentheses, 1 divided by 8, close parentheses, raised to the 9th power. Uh-oh, what happened?
E.
You got an E. And what does that mean? Scientific notation. So this is 5.960 times 10 to the negative 8. Is that a big number or a little number? Little. Does it make sense to you that if you keep multiplying by an 8, your number's just going to keep getting smaller and smaller and smaller? Okay, one more. And then I got a couple things to share. I'm going to hand back some papers and share a couple things with you. Here we go, one more. So we have -6, 18, -54. Well, this is wild. It's going back and forth, positive, negative. Well, that's okay. What's my ratio? -3. Aren't I multiplying by -3? And if you keep multiplying by -3, aren't you gonna flip back and forth? Perfectly okay. Your first term is -6. And we again want the 10th term, so here we go. According to the formula, a sub 10 will be what? -6 times -3 to the 9th. And again, if you type that in the way I wrote it, you'll be fine. So -6 parentheses, -3, close parentheses, raised to the 9th power. I got 118,098, so 118,098. Is that what you got? Okay. Now we'll look at something real quick. Yeah. We're not quite ready, for an assignment yet, so you're not gonna assign it just yet, but I'm gonna stop there, because I wanna share something with you and get some papers handed back. Do you guys know, the Michael kids, like Andrew Michael and, Isaac graduated, you know, okay? He's in your class, Andrew is, anyway. So, anyway, I taught their mom, and she was really smart, and back, I don't know, I had her as a sophomore or junior, I don't remember, she came walking in one day and said, this was back in the 80s, Mrs. Ford, my dad and I were watching TV last night, and they said something on TV that can't possibly be true, it just doesn't make sense. And my dad suggested we talk about it in math class, and I said, okay, sure, let's talk about it. And she said, all right, they said on TV that if you take a checkerboard, you seen a checkerboard before, like a chessboard? If you take a regular old checkerboard that's 8 by 8, so it has 8, it's 8 by 8. If you put one checker on the first square, 2 on the next square, and then 4, and then 8, and then 16, and so on, and you do that for the whole checkerboard, by the time you get to this last square, so you just keep, you know, putting more and more on, by the time you get to that last square, you'll have enough checkers stacked up to reach the nearest star. And she said, well, even if we think of the sun as the nearest star, that's 93 million miles away. That just doesn't make sense, that we'd have enough checkers stacked up. Well, let's think about this. There's 64 squares here. Would you agree that the sequence of checkers is geometric? I'm doubling, timesing by 2. So I'm going to use this formula, it's geometric, and I'm going to find the 64th term, because there are 64 squares and I want the last one. So what does my formula say? Take the first term, which is 1, multiply it by the ratio, which is 2, to the 63rd power, 64 minus 1. Let's type that in on our calculator. Basically, it's 2 to the 63rd. Now, that's scientific notation, right? Times 10 to the 18th. Whoa, 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 that's a big number. But remember, that's not a distance, that's how many checkers there are. So if you think about piling checkers on top of each other, how many would make an inch, do you think? That's about an inch there. How many would make an inch?
4, 3.
Maybe 3. 4, they'd have to be really skinny, but 2.5 or 3 probably. So let's take that number and let's divide it by 3. Now this is how many inches I have. So let's divide that by 12. And what will that give me? how many feet I have. And let's divide that by 5,280. 5,280. That'll give me how many miles of checkers I have. Guys, that's 4.85 times 10 to the 13th miles of checkers. Keep in mind that the sun is 10 to the 7th. This is way past the sun, right? It's the sun squared almost. Isn't that incredible? Absolutely incredible. Absolutely incredible. All right, while we're on that topic, I'll share one more story, but I gotta turn this off because I don't want to make feelings to get hurt.